All right, in this second video, we are going to review how to use the chain rule. So remember that the chain rule has to be applied anytime we're working with a composite function. You always want to try to be able to identify an inside and an outside for that particular function. The chain rule, this was back at the beginning of this notes section, but if my function is, if I have a function that's f of u, where u is some sort of expression, then if I take the derivative of that, the rule is that it's going to be the derivative of the outside, leave the inside alone, times the derivative of the inside is how that's going to work. So if we look at number 5, we want to find the derivative of the square root of 9x minus 4. 9x minus 4 is our inside. Anytime we're working with radicals, we want to rewrite them as a power. So this is equivalent to 9x minus 4 to the 1/2 power. So the chain rule says, take the derivative of the outside, so that's going to be a power rule. We're going to multiply by 1/2. Subtract 1 from the exponent, so now that's negative 1/2, and we leave the inside alone. Then we multiply by the derivative of the inside, which in this case is 9. So now let's clean this up a little bit. What we get for our derivative is going to be 9 is going to be on the top over 2 times the square root of 9x minus 4. The negative power moves it to the denominator. So there's our derivative. Okay. For number 6, when we practiced our calculator circuits, we saw a little bit how this works. When we write down tangent squared, the way that you see that written there, what this really means is the tangent of 3x squared. So this one is a double chain rule. We have 3x is the most on the inside, then tangent 3x is part inside, and then squared is the outside. So we work from the outside in. So to find our derivative, f prime of x, we're going to start with our power rule on the outside. Multiply by the 2. 2 times tangent of 3x. And then subtract 1 from the exponent. So that's just the first. We don't need that, but I'm going to write it here just so we can see what's happening. Now we need to take the derivative of tangent 3x. So times the derivative of tangent is secant squared. And we leave the inside alone. And then we need to take the derivative of the most inside, which is 3x. So we have times 3. And so now we can tidy this up just the tiniest bit. We can multiply the 2 and the 3, but that's really all we can do. So we get 6 tangent 3x secant squared 3x. And that is what we get. You can't really simplify any more than that. But this is a great example of multiple layers and having to work from the inside out. So what I would encourage you to do is go ahead and put the video on pause and try number 7 and number 8 on your own. Notice that number 8 is working with a second derivative. It's not necessarily a chain rule at the beginning, but that second derivative is going to get you to where you might need to use a chain rule, I think. And then number 7 is just kind of ugly, so take it piece by piece. But this will be a really good check for yourself to see if you've got this review and if you know what it is you're doing. So pause your video. I'll come back here with answers in 3 seconds. All right, this first one doesn't come out nearly as bad as it looks like it's going to be at the beginning, because we do have to do a quotient rule once we get to the inside. So to start, remember we want derivative of the outside, so that's where the 6 comes from. Subtract 1, we get 5. That's the outside part. Now the chain is the derivative of the inside. So f prime g minus g prime f all over g squared. I went ahead and did some kind of scratch work here to multiply that out so that I could combine everything, and this is what we get. And then in my last step, I factored the negative out of all of this and brought it out in front of the 6. So that's why the sign switched there. You notice that these are the same base, so we can add the exponents. And this is our final, most simplified, factored, all that good stuff answer. Okay? So let's start with the first derivative for number 8. So this would really be the answer that we would want to stick with for that first derivative. F prime g minus g prime f over g prime. But this is why this is in this chain rule practice category. When I go to take the second derivative, it's definitely going to be more convenient for me if I rewrite it like this. Okay, so I'm going to now, when we take our second derivative, it's not a product rule because that's just a constant multiplier, so we can just bring it along for the ride. And in fact, when we take the derivative, we're going to multiply by the -1, so that's going to make the 3 negative, times x plus 3 to the -2 times the derivative of the inside, which is just going to be 1. But we can rewrite that as -3 over x plus 3 to the positive 2 power. That is our second derivative. Okay? The last example here is another practice writing the equation of the tangent line. So we saw that in the previous video. You need a slope, you need a point, and then you want to use your point-slope equation to come up with that answer. So pause your video, give that a try yourself, and then come back here in 3 seconds. So here's sort of a checkpoint midway. So we have to first find our derivative. You get 27 times 9x plus 7 squared. We need the value of that derivative at -1 because that's going to give us the slope of our tangent line. So I get 108. Yes, that's a big slope. Doesn't make it wrong. Then we need the ordered pair. So we know that x is equal to 1. To figure out the y, we need f of -1, which comes out to -2 cubed, which is -8. So this is the ordered pair that we are working with. And so once again, my pen turned off. We want to use the point-slope equation, y minus y1 equals m times x minus x1. So we get y plus 8 equals 108 times x plus 1. And you can stop right there. There's our equation in point-slope form. We are good to go, and that's that. So now we have reviewed our chain rule, and you're going to get to do a little bit of practice with derivatives over the next couple days.